table looks after it's been built. And I'm going to go back out so Matt can see, because it looked like the screen may not have been showing, and rebuild the functional movement assessment. Or actually, I'll do a bilateral weight asymmetry one so everybody can see the parameter being built. So we're going to add a new parameter set. We're going to call it bilateral weight asymmetry. Weight scales. We save the parameter. We come down, and now we'll actually build the table. Again, you can change the title. Here we're going to go with a percentage, so basically it's going to be a difference in the scales. Basically this is a way to show posture deviation of balance. It is like an alignment for the car. You don't want to wear out one side versus the other side of the body. We would save that. So this kind of gives a description. Then we would modify the data table to actually load it. Again, a good score here, we'd be looking at less than a 2% change. So in this case, we're going to go from the upper to the lower. 10, 9, 8, 7, 6, 5, 4. So we have our rating tables. And here we would add our values. So in this case, we're saying that anything that's greater than or equal to, sometimes adding a 0 on this table will create a little bit of an issue. So we're using -1 to make sure everything falls in. So greater than or equal to -1, up through 2%, 2 to 4, 4 to 6. These values will fill in. So right now I'm giving a 2% change. If it's less than 2%, the person's going to get a rating of 10. So if they weighed 200 pounds and they had a 4 pound difference on the actual scale, they would be at that 2%, and that would work. They would get a rating of 10. Just going down to fill out the scale. And then we want to check off the ideal ones. So by checking off the ideal ones, this actually gives us the rating table. So this is a parameter for the bilateral weight asymmetry, bilateral weight scales. There's the ideal. We're going to save it, and I'm going to show you the actual data table being produced. Behind the scenes, the data table is here. So you can kind of see less than 2. It's going to give a rating of 10. Now in this case, I put -1. The ideal range is going to take those values that have been checked off. I don't like -1 as an ideal range because nobody's going to be under 0. So I'm going to go back and just show you if you make a mistake on a data table, you can go ahead and change that or update it. So I'm going to change that to 0. Hit update. You see the value changed. I'm going to go back to my data table, and now you see that the ideal range is 0 to less than 4%. So that's it in a nutshell as far as building a simple data table. This one I showed going from a low value and getting a high rating. I'm going to do one more since the screen was blank initially when I did the functional movement assessment, so you guys can see one that's built in the opposite direction. Same principle is provided. Okay, we're going to go into parameters again. I'm going to go ahead and add a new parameter. I'm just going to call it a test. I'll actually call it, because I have a couple tests in there, I'm going to call it webinar. And I'll do the one that initially you guys weren't able to see with the functional movement on 50 points. Go ahead, once you have actually saved the parameter name, then you go back and find it, webinar, you hit the parameter, modify. Basically, you would type in all the information, units, points, if there's any qualifiers, what the reference is, description of that parameter, functional movement screening, and then I would actually list the tests. So, what the tests were and how much the points are for each one. You go ahead and save that so that then when you print out the score sheet, everybody can see it. And again, to modify the data table, this is your tab to go ahead in. And in this case, we're building the rating table for larger values. So the ratings are just going to go in the opposite direction in the sense that from the ideal standpoint, so our rating's 0 through, instead of 10, down. You have to decide on what your scale is, or if you're actually punching in a scale based upon a set of tests, what your reference is. Make sure that you divide it. You don't have to have ratings of 10. You can do one that would have ratings of 0, 2.5, 5, 7.5, 10. You can build a rating table based upon the number of measurements. The core flexibility and the core testing is set up that way. In that sense, because we're only doing 4 tests. Here for score, in this case we want to make sure that 0 is included, so we actually do have a -1. It's not going to show up in the ideal range. So in reality, 0 to 5 is going to give a score of 0. 5 to 10 is going to give a score of 1. 10 to 15 is going to give a score of 2. 15 to 20, and so on. Just walking it up. And 50. And we need to add 50 to make sure that if somebody gets a perfect score, that's included, because here it's less than 50. Again, the ideal ranges are 10, 9, and 8. That way that shows up on the scoring. When the person gets their scores, you have an ideal range so they know what's happening. Here's your data table. And again, this shows the actual table itself. Now in this case, I built a couple other ones that were same exact as this. You don't like what you built, or you don't want to have that as part of your system anymore, you can actually just go ahead and hit. Here I did bilateral scales again. Yesterday I did bilateral weight asymmetry just to kind of get myself ready for the webinar. I hit that. I delete it. Anything that you build is only on your system. So basically you're adding and deleting within your own system. It's not affecting anybody else's scores, not affecting any items in that case. So that's fine. And then I'm going to take you out and